Hello, this is Captain Chaudhary. Today I am going to do a numerical on draft survey. This numerical is from my book called Stability, and we are going to do a numerical on Alpha ship. The Alpha ship is the demo ship in my book. The question reads like MV Alpha ship is in density 1.012 after completion of the discharge had drafts forward port and starboard 4.2, 4.22, aft port and starboard 6.24, 6.50, midships 5.13, 5.53. Find the displacement. The length of the ship is 171.792. Now the drafts forward, aft and midship are located like this. The forward draft is 2 meters aft of 4 perpendicular. Midship draft is 3 meters aft of midships, and aft draft is 3 meters forward of aft perpendicular. These are the data that will be required to do the numerical, and I've taken it from the hydrostatic table of MV Alpha ship. If the ship was box shaped, we would have said whatever is the water line at the forward end and aft end, take the mean of the two, and what is the draft? What is the displacement for the draft is the correct displacement, assuming there is no hogging and sagging. Now here the problem is the ship is ship shaped. So to somehow compensate for the shape of the vessel, somehow to compensate for the hog and sag, we find the displacement for quarter mean draft, and thereafter we do certain more corrections, the second trim correction and also the list correction, and I will explain you why we do those corrections. But to start with, let us find out what are the drafts at these perpendiculars. I will try to draw the ship and explain you step by step how we go about doing these corrections. So let us say that the ship is like this. Here is the aft perpendicular. Now, this is say a water line, and let us say this is the fore perpendicular. The forward draft is 2 meters aft of the fore perpendicular. So if this is the forward draft, this distance is 2 meters. And the midship draft is 3 meters aft of midship. So suppose this is midships. 3 meters aft of the midships is the aft draft. Every numerical that you do should be accompanied by the diagram. You are likely to make less mistakes, and even if clerically something goes wrong, you are likely to get more marks. So I have done that. Now this is aft perpendicular, and aft draft are 3 meters forward of the aft perpendicular. So this is how the marking is of the drafts. And if you see the total distance from fore perpendicular to the aft perpendicular, it is 171.792 meters. So if I ask you what is the distance between the drafts, so you would say 171.792 minus 5 meters. So 166.792 meters is the distance between drafts. 166.792 meters is the distance between. And now what is the apparent trim? So if you see the forward draft, the mean of the forward draft is 4.21 meters, and mean of the aft drafts 6.24 plus 6.50 equal to divided by 2. Mean of the aft draft is 6.37, right? So mean of aft draft is 6.37. So what is the trim? 2.16 meters. Now this 2.16 meters is the apparent trim, and this trim is found on the basis of the drafts which are marked forward and aft, right? So if we say 2.16 is the difference of draft at this point and this point, and the distance between them is 166.792. Okay, this is the apparent trim. This is not the actual trim. This is apparent trim because of the drafts which are placed 166.792 meters. Then this particular ratio will help us to find out what is the correction to be applied to these drafts, to find out the drafts at perpendiculars and midships. Like for example, this ratio actually is same as trim upon LBP. So in the question, wherever you want to use trim upon LBP, you can actually use this ratio, right? So this ratio, whatever it is, we'll be able to find out all the trim corrections from forward to aft. So let us say for this distance of 2 meters, what is the trim correction? So it would be 2.16 into 2 equal to divide by 166.792. That gives me 0.026 meters. And what is the correction for a distance of 3 meters, which will be applied here as well as here? So it is 2.16 into 3 equal to divide by 166.792. That gives me 0.039. That means the correction that will be applied to the forward draft will be equal to 0.026 meters. And let me tell you, the ship is actually trimmed by stern, so every forward draft has to be less than every aft draft. That means the draft at 4 perpendicular will be less than this. Okay, so this correction is going to be negative. What about this correction? I want to find out the draft at midships, whereas the draft that is read at this point. Now the distance is 3 meters, and this draft also has to be less than the red draft, so it will be negative correction over here also. But here I have read the draft over here, but I want the draft which is aft of this place. Aft means the draft has to be more than this, so this correction is going to be positive. So can I say the corrected draft for the position forward is going to be 4.21 minus 0.026, and aft is going to be 6.37 plus 0.039, and at midship it will be, the mean of midship draft is how much? 5.13, 5.53. The difference is 0.4. 5.33 is the mean. So mean 5.33, and the correction is negative minus 0.039. So the forward draft. So the forward draft is 4.184, and the aft draft is going to be 6.37 plus 0.039. That gives me 6.409, and the midship draft is 5.33 minus 0.039. That gives me 5.291. Now, as I said, we have to give allowance to the hull, the sag, and the shape of the vessel, and also understanding that the ship's cargo carrying body is mainly midship. Ship basically gives the buoyancy because of the midship area more than the forward and aft. So more weightage is given to the midship draft than the forward and aft draft. This is done by multiplying the forward draft with 1, aft with 1, and midship by 6, and dividing everything by 8. Right? So forward into 1, aft into 1, and midship into 6. Let us see how much you get. So 5.291 into 6 equal to plus 4.184 equal to plus 6.409 equal to divided by 8 gives me 5.292 meters. So 5.292 meters. So 5.292 meters is the mean of mean. Sometimes it is also called quarter mean draft. So after finding out the quarter mean draft or mean of mean draft, we want to now find out what is the draft at center of flotation. So let's look at the ship trimmed. Let's look at the ship trimmed by aft. We know what is the ratio between the trim and the length. What we have found out is the draft at midships. So this draft we have got as 5.292 meters. But we want to find out the draft at center of flotation. Now, how much is this point forward of the aft perpendicular can be found out by the length divided by 2. So 171.792 divided by 2, that gives me 85.896. So the distance from here is 85.896. That is the distance from here to here. But I want to find out, say for this draft 5.292. Presently the ship is on this draft, right? We don't have hydrostatic draft, but we may assume that this is more or less close to hydrostatic draft. So for 5.292, let us see what is the position of center of flotation. So we look at this 5.2 and 5.4, and the center of flotations for 5.2 and 5.4 are 87.415, 87.313. As I told you before also, to interpolate, the left hand side column should be in the increasing order. So it is in the increasing order. The difference of 5.2 and 5.4 is 0.2, which I write in the denominator. And the difference between 5.292 and 5.2 is 0.092, which I write down on top. So let us see what is this factor. This gives me the factor for interpolation. So 0.092 divided by 0.2 gives me 0.46. So this gives me 0.46. This is the factor of interpolation. LCF, as you can see, it is decreasing, but I don't care whether it is increasing or decreasing. I take the second value, that is 87.313, minus the first value 87.415 equal to, multiplied by factor 0.46 equal to, plus the first value 87.415. 87.415 gives me 87.368. 87.368 is the position of center of flotation from the aft. So that means the center of flotation is forward of midship. So that is 87.368, the position of center of flotation. So as you can see from the diagram, we have found out this draft, and we want to find out the draft at center of flotation. That means I want to find out this draft. You can see from the drawing, every forward draft has to be less than every aft draft. What is the distance between the center of flotation and the midships? Let us find out. 87.368 minus 85.896. That gives me 1.472. The distance is 1.472. This is the distance by which center of flotation is forward of midships. So I want to find out what is the draft there. So I want to apply the correction for 1.472 using the same ratio, that is 2.16 upon 166.792. So 1.472 into 2.16 equal to, divide by 166.792. That gives me 0.019. 0.019. So whatever is my quarter mean draft, that is 5.292, from there I should minus 0.019. What I get is 5.273. So 5.273, I suppose, is the draft at center of flotation. At the moment, the center of flotation, which is the center of flotation for an even keel vessel, but we will discuss that matter a little later. What I presently want to find out, if I know the forward draft, if I know the aft draft, and if I know the draft at center of flotation, that is 5.273, can I find out what is the displacement for this draft? What is the displacement for 5.273? So I will interpolate between 5.2 and 5.4. Once again, the factor is found in the similar way. That is, in the denominator I will write 0.2, and in the numerator I will write 0.073. 0.073, because I want to find out what is the displacement for 5.273. 5.273 minus 5.2 is 0.073, which I have written on top. 0.073 divided by 0.2 gives me 0.365. The factor is 0.365. I will use this factor to find out what is the displacement for this draft 5.273. So what I do is, as usual, 14943.5, that is the second value, minus the first value 14322 equal to, multiplied by factor 0.365 equal to whatever I get, add to the first value 14322. That gives me 14548.84. This displacement has accounted for the first trim correction, right? So we have understood the first trim correction just by the drawing, right? We don't have to remember any formula. What we have done initially is we have found out what are the drafts at the perpendiculars and the midship, and then forward plus aft plus 6 times midships divided by 8 gave me the quarter mean draft. For the quarter mean draft, I saw what is the center of flotation, and I found that the center of flotation is forward of the midship. I wanted to know what is the draft at center of flotation, and for that draft, when I read the displacement, it came out to be 14548.84 tons. So first trim correction has already been applied, and thereby I get the displacement which is written over here. Now let us apply the second trim correction. But to understand second trim correction, we must know how and why it is applied and why it is always positive. Yes, you would like to know why it is always positive. Let us try and understand. The position of center of flotation is so many meters forward of the aft perpendicular. At that position, we have found the draft in the trimmed condition. Okay, now we want to find out if the vessel is trimmed, then whether the center of flotation is there where the vessel is in the even keel posture, or the center of flotation position changes. So for that, let us understand this diagram. Okay, here is the ship. And let us say this is the trimmed condition of the vessel. Now from the aft perpendicular, we have found out where is the position of center of flotation as the vessel is on even keel. So we found that for the draft that we have obtained so far, if the ship was on even keel, the center of flotation position is here. As you know, the center of flotation is the centroid of water plane area. Now as the ship pivots about this point and the vessel trims by stern, you can see that the water plane area would increase, and therefore the center of flotation would shift off. Whereas if the ship trims by head, then looking at the flare, looking at the increasing flare and water plane area, it is surely going to shift in forward direction. It means from the even keel posture, in whichever direction the vessel trims, the center of flotation would slightly move in that direction. Now in this particular case, what has happened is the vessel is trimmed by stern. We would assume that from the even keel posture, the center of flotation would have shifted in that direction. That means if we consider this particular draft where the vessel is trimmed by stern, the center of flotation is not over here, which we have found from the table, but the center of flotation is over here. And you can see that the new position of center of flotation is the place where we must read the draft, and that draft is bound to be more than the draft at the original center of flotation, which is for even keel. Now, because the draft at the center of flotation, which is in trimmed condition, is more than the draft at center of flotation, which was in even keel posture, this correction is always positive. Now, this correction would be positive even if the vessel was trimmed by hand. So that's why we say that the second trim correction is always positive. Now, what is the formula for this correction? The formula for that is 50 into trim square. Trim is to be taken in a meter. 50 into trim square, right? Multiplied by difference of MCTCs and divided by LBP. Now, MCTC has to be seen for the drafts. The present draft that we have found out so far, minus 50 centimeter and plus 50 centimeters. We will do that calculation now. We'll put it in the formula 50T square into difference of MCTC divided by LBP. This correction will come in tons, and this correction is always positive. We have already discussed about it. Now the trim, which is written here in meters and is square, we can take the trim between the perpendiculars. So that is 6.409 minus 4.184. So that is 2.225 meters. And let us look at the MCTCs. The MCTCs can be seen for these drafts, that is 4.773 and 5.773. So for finding out MCTC for 4.773, I would interpolate between 4.6 and 4.8 over here. The MCTC for 4.6 is 229.3, for 4.8 is 231.6, right? Now, as usual, I'll write the difference between 4.6 and 4.8 here, that is 0.2, and the difference between 4.6 and 4.773 is 0.173, and this fraction for the interpolation is 0.173 divided by 0.2, that gives me 0.865. And the usual way of interpolation, 231.6 minus 229.3 equal to multiplied by 0.865 equal to whatever I get plus the first value 229.3 gives me 231.29, that is MCTC1. And now for 5.773, the fraction would be same. If I interpolate between 5.6 and 5.8, right? The fraction would be same, gives me 241.13, 241.13. So the difference is 9.84. So that is M1 difference M2, 9.84. LBP is 171.792. So I'll put the values in the formula 50 into 2.225 into 9.84, this is square, divided by 171.792, gives me 14.178. 14.178. So 14.178 is the second trim correction. Right? So we have reached the second trim correction. Correction is in tons. So we add to the previously found displacement, which was corrected for the first trim correction, that is 1454.8.84 tons, plus 14.18. Now we advance towards the list correction. Now in this particular question the vessel is listed. Let me draw a transverse view of the ship in the listed condition. Now this is the draft we want to find out. Whether the vessel is listed on port side or starboard side, on the center line, this is the draft. We want to find out this draft. So assume that the vessel is listed like this. Here is a wedge that is formed and here is another wedge that is formed. The volumes must be equal. The volume of this wedge and that wedge must be equal. If you look at the diagram, like if you consider that this is representing the average transverse section of the ship. Now this side has to be equal to this side. Obviously by the geometry what you can see is this side is equal to this side. But you know, from here onwards the ship's hull is coming inwards and from here the ship's hull is going outwards. So you agree that this particular distance is smaller than this particular distance. This distance is less than this distance, which you can see. Now if the volumes are equal and this distance is less than this distance, to compensate for that, this distance has to be more than this distance. Now this waterline submersion here is more than the waterline raise on the other side, which means that on this side also we are reading a lower draft and on this side also we are reading a lower draft, and the mean of the two draft, the average of the two draft is going to take to a draft that is lower than the actual draft. Once again the two volumes are equal. This side is equal to this side, but this side is smaller than this side, and because this side is smaller, to compensate for, to get to the correct volume, this immersion or this side has to be bigger than this side. That means this water level comes down and this water level also comes down. The mean of the two water levels is less than the actual water level, which means that what we have found out as mean draft, what we have found out as the mean draft is actually not correct. It is smaller than the actual. So this correction is also positive, and the formula for that is 6 times the difference of TPCs, delta TPC, into difference of the draft. 6 times the difference of TPCs multiplied by difference of the draft. Ideally we should take the draft which represents the displacement of the vessel. But because we are finding out not the draft, we are writing down the difference of the drafts. What can be done is you can take the observed midship drafts which were observed initially. We can use 5.13 and 5.53 which were the originally observed midship drafts for finding out what is the difference of drafts, and we can see the relevant TPCs for those drafts, because when we find the difference, if there is any error because of the trim etc., that error will be eliminated. Okay, let's go for it. So the list correction is 6 times delta TPC into delta draft. 6 times the difference of draft, 5.13 into 5.53, that is 0.40. And now let's look at the TPCs. The TPC I want to see for 5.13, so I must interpolate between 5 and 5.2. The difference is 0.2, so 0.13 upon 0.2 is the factor. 0.13 divided by 0.2, that gives me 0.65. 0.65 is going to be the factor. So the TPC for 5.13 would be 31.13 minus 31.02 equal to, multiplied by the factor 0.65 equal to, plus 31.02 gives me 31.092. 31.092. And to find out the TPC for 5.53, I interpolate between 5.4 and 5.6. Gives me 31.305. 31.305. minus 31.092 gives me 0.213. So multiplied by 0.213. So 0.213 into 0.4 into 6 gives me 0.51 is the correction. So the displacement corrected for the trim one is 14548.84, second trim correction 14.18, and the list correction 0.51. I will add all of them. 14563.53. 14563.53 would be the displacement if the vessel was floating in salt water, but the vessel is not floating in salt water. The density is 1.012. Dock water density is 1.012. To get the correct displacement, we must multiply with the dock water density and divide by salt water density, because the tables are made for salt water. So the correct displacement will be 14563.53 into 1.012 divided by 1.025 gives me 14378.82 tons. So this is the final displacement after doing all the corrections: the first trim correction, the second trim correction, the list correction, and the density correction.